Here is 5 uh, questions and answers from an exam I use in my business analytics class that relates to present value and future value. So I've shared a link on our discovery page. From that, when you click that link, you'll get a prompt to make a copy. So that way you can get in here, you can change values, and it's your own version, say it in your own Google Drive. So have at it. I'm not going to go through these in full detail, but hopefully it gives you a sense of the kind of things you can do with the spreadsheet, and you may see something similar in this class. So this first example looks uh, kind of like our 5-year mortgage example that I talked about just before this. Now, though, it's 30 years and it's monthly payments. So you have to make a few adjustments, adjust the interest rate to be a monthly amount, and the number of payments here is it's times the number of years times 12 for months. But other than that, and again, this, if you scroll down here, I'll show you, it keeps on going. So the payment's 477 at the end, way down here. Oops. Okay, a good check right at the end. There's a zero balance. Okay. Something else, two other things I've added to this prominently. One is basically this question is asking to compare what's better, a 15-year or 30-year mortgage. And a common thing you will hear or may hear is that, oh, if you pay it off in 15 years, you save $120,000 of interest. Well, that's true in a sense, but really there's some trade-offs. If you're paying it off sooner, it means you're spending more money on your mortgage than you are, say, investing in the stock market. An interesting result is if the 30-year mortgage rate and the 15-year mortgage rate are the same, so say both at 4%, and that the stock market also returns 4%, then the two mortgages, 15 or 30 years, are equivalent. So I'll let you go through this here. Again, one other thing I did here is when you scroll down, make sure I remember how to do this. View. Yes, freeze. Okay. So you can freeze a certain number of rows. You can click, and that way when you scroll down, you don't lose especially your column headings, and then all of a sudden it just looks like numbers that you may not be able to remember exactly what they were. So anyway, this is a pretty involved mortgage example. Can't get too much more involved in this, but you can look through this and what have you. So yeah, this is from an old exam. You can see the questions here. This one is a retirement one. So some of these, yeah, it's not just, mortgages are pretty cut and dry, but when you get into people's retirement, well, it depends on how old they are, when they want to retire, how much income, how much they're saving out of that income. So basically, yes, here Gary wants to save retirement. He's 25-year-old. He already has $50,000 saved, and he's going to save $1,000 every year plus 12% of his income. That's currently $40,000. That's his income. And his income will grow by 5% each year. Okay? And there's a couple other things here about randomness. So here is, again, it's a timeline, so it's not, oh, what's the one formula here? This could even change. Maybe when he turns 50, he starts saving 25% or what have you. So here is if he gets exactly 5% return every year. In some ways it's a simplification rather than adding the complication that this example had that, well, on average it's 5%, which means things can jump around. So we'll just focus on kind of this green answer here. So he has savings. On that, he earns 5% interest. He has an income starting at $40,000, and he saves 1,000 of that plus an additional 12% of 40,000. Okay, and then from there, so then we'd add his old savings plus the interest plus the new savings, new contributions to get the new level of savings at age 26, and then the process just repeats itself. Okay? So again, once you get the first couple years set up, you can just highlight that, copy and paste it down. In the end, we can see, when he's 50, he has over $600,000. Good job, Gary. Okay. And by the time he's 65, he has $1.7 million. So, uh, you could change this example maybe to fit your own. If you're 35 years old now, maybe you save um, a different percentage of your income. So, all right. So that's the retirement example. Those are two very classic examples of present value and future value, maybe the two most prominent. Here's one about the lottery. So in Kentucky, we have a big lottery system. I guess most places do now. And some ways they report the numbers are not really, in financial terms, not accurate, because they will collect, let's see here, just use an example. They want to have a game that pays out 250 million, and the game collects 300 million, but pays out 60% of this to college students. So how can they collect $300 million, give $180 million of that to for Keys money here in Kentucky, $2,500 a year for those with really good grades, and then only have $120 million to pay out $250 million. Well, you can kind of work this example here that if they collect the money up front, they're not paying all 250 million out right away. They're stretching it out over a quarter of a century. So it's kind of a fun example. It's not like it's part of the game that they exaggerate the payouts because they report. It's similar to our total interest paid for a mortgage. Those payments or charges are in different time periods. So that's the whole idea of time value of money. You can't just add numbers over time. You have to discount them. So, all right. Fourth one here. All right. A college fund for Ashley. Okay. And I think this looks again at two different scenarios. What if they contribute $1,000 times her birthday? So when she's 1, she gets 1,000. When she's 2, 2,000. When she's 9, she gets 9,000. Contribute to that fund. In the meantime, any money that's been added is growing at 8%. Then an alternative is if they contribute more up front on her first birthday and then $1,000, so it's front loaded. And that changes the return because, again, time value of money. The parents are putting in money earlier, so it has longer time to grow, or the bigger chunks of money are coming in earlier rather than when she's 18 or 17 or 16. So, all right. Again, I'm not going through all the details here, but I think if you can read through these, you can understand the examples, and you're welcome to change things. Okay. So this is a similar example. Now we got Sam, and he already has assets of 150,000. He has income that's growing over time to age 70 when he retires. And this is what they call a life cycle problem. Then he wants to have enough money when he retires to last another 30 years until he turns 100. So then the question is, how can he do that? So this is a classic personal finance example. It has some simplifications. Number one, most people, especially men, do not live to 100. So if he dies before that, under this plan, he'd have money left over. Secondly, most people probably put their spending first. Say, well, I'm just going to spend what I feel like I have to or want to, or maybe need to, and then let the money run out when it does. But this still gives some perspective on, well, how much could this guy spend? So it turns out, yeah, it's about $50,000 a year during his working years, and then if he holds that constant Eventually, when he retires, he has uh, almost $1 million at 71. But then that money is spent down, so a little bit of rounding here, but basically he has um, nothing left. So this is a good example too of, well, is there one formula? And you could maybe integrate some future value formulas in here, but as I say here, it's one way, and especially more complex problems. Sometimes you just have to guess and check. It's kind of like life. I don't know exactly, you know, um, how to, there's not a formula for exactly how much to save every year, but I kind of just experiment. Or maybe, there's other examples. How do you know how much to eat? Well, I just kind of eat till I'm, well, not hungry anymore. And if I find my clothes aren't fitting anymore, then maybe I'm overeating. So it's kind of a guess and check method. I don't know if that was a great example, but one that came to mind. So, all right, so there's a little bit of explanatory notes over here. If you can solve these five or understand them, you're good to go in this class. There'll be other variations of this when we do investments, but for personal finance, for household kind of decisions, these are really the core models. All right, enjoy.